Have you ever looked at a web automation framework and just felt completely lost? You see all these names, Java, Selenium, Maven, TestNG, and it feels like a giant puzzle, but you don't even have the picture on the box. Well, today, we're going to put that puzzle together. Let's dive in and demystify this entire toolkit piece by piece. Before we get into the weeds, I want you to burn this slide into your brain. Seriously, this is your mental map for everything we're about to cover. Java is for writing the instructions. Maven goes and gets the tools. Selenium is the one actually doing the actions. POM helps you keep your code organized. TestNG runs the whole show. And extent reports, well, it makes the final results look great. If you can remember this, everything else will just click into place. So here's our game plan for building out this toolkit. We're going to start with the foundation, then we'll set up our workspace. After that, we'll fire up the engine, bring in the conductor to manage everything, get the verdict on our tests, and then we'll wrap it all up with the grand finale. All right, first things first. Every great project, I don't care what it is, needs a solid foundation. For us, that means picking our language and figuring out a smart way to manage all the different tools we're about to use. The core of our foundation is going to be Java. Think of it like this. Java is the language you use to write the script for a robot. It's how you tell it all the logic, all the steps, all the instructions. It's the brains behind the operation, but it doesn't actually move the robot's arms itself. So, why Java? Why not something else? Well, it's pretty simple actually. All the major tools we're going to use, Selenium, TestNG, extent reports, they're all built with Java. It's the one language they all understand. By using Java, we make sure all the different parts of our toolkit can talk to each other perfectly. Okay, so how do we actually get all these Java-based tools? Are we going to go download a bunch of files manually? No way! That's where Maven comes in. Maven is like your project's personal assistant. You just give it a shopping list of the tools you need, and it goes out and automatically fetches and manages everything for you. It's a total game changer. And Maven is so much more than just a downloader. It uses this one central file, called the pom.xml, to manage everything. And this is huge, because it means that you and everyone else on your team are guaranteed to be using the exact same version of every single tool. This completely gets rid of those awful, well, it works on my machine problems. All right, so we've got our language and our amazing tool manager. Now we need to set up the actual workshop where all the magic is going to happen. Let's talk about the workspace. Your main workspace is going to be your IDE, which stands for Integrated Development Environment. You've probably heard of the big ones like IntelliJ or Eclipse. Think of your IDE as your command center. It's smart enough to read that pom.xml file, it uses Maven to get your tools, it gives you a place to write all your Java code, and it has the buttons to run your tests. It's where everything comes together. Now, here's a pro tip for setting up a really smart workspace. Use configuration files. These are just simple little text files where you store settings that might change, things like a website's URL or which browser you want to test on. And why is this so important? It's all about making your life easier later on. Think about it. Instead of having to dig through your code to change a web address, you just change one line in a simple text file. Want to run your entire test suite on Firefox instead of Chrome? Boom, one little edit. No coding required. It's all about working smarter, not harder. Okay, our workshop is all set up and organized. Now it's time to bring in the heavy machinery. Let's install the engine that's going to do all the actual work on the web. Let's talk Selenium. So what exactly is Selenium? It's the engine of our entire operation. It's the tool that gives our Java code the power to actually take control of a web browser. Anytime your script needs to click a button, type into a search bar, or grab some text off the screen, that's Selenium doing the work. It's the robot arms, actually interacting with the world. Now, this is a super important point, and it's one that trips up a lot of beginners. Selenium is just an actor. It does exactly what the script tells it to do, but it has zero opinions. It doesn't know if clicking that button was the right thing to do. It has no idea if a test passed or failed. It just clicks and types and waits for its next instruction. Determining the outcome? That's a job for a different tool. So with all these Selenium commands flying around, how do we keep things from getting messy? We use a design pattern called the Page Object Model, or POM. Now listen, this is not a tool you download. It's a blueprint for how to structure your code. The idea is brilliant and simple. For every single page on your website, like the home page or the login page, you create one single Java file to hold all of its buttons, links, and actions. This keeps your code incredibly clean and so much easier to maintain. Okay, so we've got an engine that can perform actions, but we need someone to direct the show, right? To tell the engine when to start, when to stop, and what to do. It's time to bring in our conductor, the TestNG framework.
So let's be crystal clear about the difference here. Think of it like an orchestra. Selenium is the first violin. It's playing the notes, interacting with the instrument, but TestNG is the conductor. It tells the violin when to play, organizes the entire performance, and at the very end, decides if the show is a success or a failure. They do two very different but equally important jobs.
And TestNG is a whole lot more than just a run button. It's a powerhouse. It uses these things called annotations, which are like little sticky notes you put on your code to say, hey, TestNG, this is a test. It has assertions, which are what actually decide if a test passes or fails. It has listeners that can react to things happening. And it's all managed by a file called testng.xml, which lets you organize really complex test runs. It's the real brain of the whole operation. Our conductor is in place, the engine is ready to go. Now let's focus on what's arguably the most important part of this whole thing, getting a clear verdict and then presenting those results so that anybody can understand them. This right here, this is the moment of truth. An assertion is a single line of code in TestNG that acts as the judge and jury. It takes what you expected to see on the page and compares it to what Selenium actually saw. I'm going to say it again because it's that important. Without assertions, you are not testing. You're just making a browser click around. The assertion is what makes it a real test. Okay, so what are listeners? Think of them as these little automated helpers that are just listening in the background while your tests run. You can set them up to react to specific events. For example, and this is my favorite one, you can have a listener that the instant a test fails, it automatically takes a screenshot of the browser. It's an unbelievably powerful way to figure out what went wrong. Now, TestNG gives you a pretty basic report out of the box, and that's fine. But what if you need to show your results to your manager or to a client? You probably want something a little more polished. That's where a tool like Extent Reports comes in. It plugs right into TestNG, often using those listeners we just talked about, to create these beautiful professional dashboards with charts, logs, and even those screenshots. We've done it, we've collected and assembled every single piece of our automation toolkit. So now, for the grand finale, let's watch how this beautifully oiled machine works together in one single seamless flow from the moment you hit go. Okay, check this out. It all starts when you kick off the process, maybe by running a command or your testng.xml file. Instantly, Maven does a quick check to make sure all your tools are present and accounted for. Then, TestNG reads its instructions and starts running the tests. That's the signal for Selenium WebDriver to jump in, fire up a browser, and start performing all the clicks and types that you neatly organized in your page object files. After an action, TestNG's assertions check the results, giving a thumbs up or thumbs down, pass or fail. And if anything fails, that's when those listeners spring into action, automatically grabbing a screenshot and sending all the data over to your Extent report. It's like a perfectly choreographed dance. Feeling ready to build your own? Here's your simple Get Started checklist. First, install Java and an IDE. Then, create a new Maven project. Go into that pom.xml file and add your dependencies for Selenium, TestNG, and Extent. Take a little time to really understand that page object model structure. And finally, learn the basics, TestNG annotations and assertions, and how to run a testng.xml file. That's your recipe for success. So there you have it. We took that big, confusing pile of names and turned it into a fully assembled, high-performance automation toolkit. You now have the complete blueprint. The only question left is, what's the first thing you're going to build with it?